Okay, so you can see part of the Atlantic Ocean. It's the bay side, but same idea. Behind me, you can see the marsh, salt marsh. It's brackish, still salt marsh. And you can see in my pocket a shell. We're going to talk a little bit about the carbon cycle. I need to actually talk about the atmosphere and the sky above me as well. And that's all part of it too. So we're talking about the carbon cycle, a matter cycle. And matter and energy are related. We could talk about actually the fact that you can convert matter into energy, and really, does that mean that they're any different from each other? Well, the way we talk about matter and energy in this course especially is as free and usable energy, and think about entropy, and could go into thermodynamics and delta G and all that, but that is more how we're going to talk about things. So matter cycles and goes around and around, and we don't really lose. We conserve matter, right? And not that we lose energy, we just lose usable energy. So we're going to take that out of the equation for now and just talk about the matter component. And carbon is something that's important in our environment that we will continually talk about in terms of climate change. So let's do a little bit more on that. So there's carbon in everything that you're looking at. It's the basis of organic matter and therefore life, right? And there's carbon in me, there's carbon in the atmosphere and carbon dioxide. There's carbon dissolved in carbon dioxide in that ocean water, which is there as well. Those plants take in carbon dioxide through photosynthesis, and carbon is what is in all of us in our living form as well. We could also talk about respiration, cellular respiration, which we are breathing carbon dioxide out, and the plants also do cellular respiration as well. We don't do photosynthesis, but that gas exchange does occur both for plants and animals. Again, cellular respiration for both, for us and plants, right? But, photosynthesis just for the plants, or any photosynthetic organisms. Let's bring that out a bit. It's not just plants, obviously. But it's not us, not animals. So we're talking about any element that exists in living things, including carbon. As things live, they eventually do die. And as they die, they're going to release those elements into the soil, or the water, or the atmosphere as appropriate through decomposition. So carbon will be something that does that. So it's really not just where the carbon winds up. Like I said, carbon dioxide from the atmosphere will, just like any other gas, we're talking about solubility and partial pressures that influence this, but just like any other gas that's in the atmosphere in any significant quantities, is going to be dissolved into the water. And we could talk about what accelerates processes here, because again, it's timing that really matters. Being a carbon store or sink is important, especially with global climate change, where more carbon dioxide is released by things like even the engine on a boat, for example, or cars, or the airplane you hear above me. When we're burning fossil fuels, anytime we're doing that, we're releasing more carbon dioxide into the atmosphere than it's meant to hold, or it naturally holds. Meant to is kind of not the right terminology here. So things like putting it into a solid form, which takes longer for it to go back into the atmosphere, like even a shell, or you could talk about rocks as well. These are processes that take longer for the carbon to, calcium carbonate. That's in bones and shells. So limestone. These are things that can store the carbon longer and then avoid it being in the atmosphere quicker. So the ocean plays an important part in this, and that's one reason I'm doing the video here. And you can also think about all those plants that are here when the carbon is in the plant, as opposed to and being taken up by plants through photosynthesis or any other photosynthetic organisms. We could talk about phytoplankton, since we're by the ocean as well. That's important to notice too in the carbon cycle. Of course, the longer it takes for something to decompose and decay, winds up potentially, if it was a peat bog, for example, we could actually have some fossil fuels being made. Like, there's that potential too, where the carbon can be stored long term. You talk about coal being formed, and again, this is not a peat bog. This is not really going to happen here. It takes a very long time. It would talk about the idea of renewable, non-renewable resources. Renewable just means it's generated on a time scale that it comes back within our time scale. Non-renewable means it just takes so long to form that, for all intents and purposes, it's going to be something that's not regenerated in that same time. I mean, you could render a renewable resource non-renewable just by overusing it and using it too quickly to the point where it's not growing back, if it's a plant, for example. Even like logs, right? But same idea here. We can talk about forming fossil fuels again. It does happen. It just takes millions of years. So that's why it's not the main point of this video. And we could also talk about carbon sequestration, and the idea that you can, by different means, and by, talk about like geoengineering, as a matter of fact, we can remove some carbon dioxide from the atmosphere and maybe sequester it underground in a place where it's really not going to get back out there for quite some time, and store it. Or turning a parking lot into a forest. What would that do? And there's differing opinions on, and not just opinions, different data. I guess we're still really figuring this out, on how much trees really can take out of the environment, or how much different plants can, if they're young, if they're growing, if it's like something like bamboo that really shoots up and grows very fast, or an older tree, is that really doing enough? But all of it is more than you would get out of a parking lot. Just think about land use and how much can really be done that way. It is an important question. It is something that needs to be quantified a little bit better at this point, and we're working on it. People are absolutely really working on it. I'm ducking under poison ivy. I just noticed. I'm like, really don't want to get poison ivy on my head. But anything that's photosynthetic, including the prickly pear that you see there. Will take carbon dioxide out of the atmosphere, which is the goal in terms of global climate change. So, yes, carbon cycle, really important. We are altering it. There are human impacts upon it, including deforestation, taking those trees out. Obviously, that's going to impact carbon cycle, recycling the carbon back into the atmosphere quicker than we want. Factories and burning of fossil fuels, we're putting more carbon dioxide into the atmosphere as well, more quickly. Really is about scale, time scale, spatial scale. The amount of carbon dioxide and carbon in a place at any one time. And naturally what the environment can hold, there's so many variables here that it's very difficult to really have an accurate depiction. But we do know more carbon dioxide does lead to globally higher temperatures and some other climate change.